So everyone, I'd like to welcome you to our I'm a couple months ahead of myself, to our April webinar with Norm Fitton. He is with Anniversary UV, and he'll be giving us a really great seminar on UV systems. So I'll just pass it right over to Norm. We're gonna do Q&A at the end. Feel free to just drop questions into the chat box. At the end, I will give you an opportunity to also unmute and ask questions. So Norm, take it away.
Thank you, Wendy. Well, today I'm going to talk about your UV system, how it cures, and the things you need to maintain it. Anniversary's been in business for 30 years. We do lamps, reflectors, magnetic power supplies, switching relays, capacitors, and add-on UV units if you want to add to your current presses. I've been doing this for about 20 years. I'm not an engineer. Everything I've learned on the job. My primary mission is visiting customers in the field and working with their system. So I tend to be less highly technical in terms of verbiage and more user-friendly based on what I see in customers' plants. So the first thing I want to do is talk about just the overall curing process. The UV lamps are called arc lamps. The reason they're called arc lamps is because we take high power, we blow up a ball of mercury, and we create an electrical arc from electrode to electrode, which creates UV light. There is no filament in these lamps. The process is photochemical, which means we set your ink, your varnish instantly. And that's done with photoinitiators in your ink. So conventional inks have no photoinitiators. UV inks have photoinitiators that respond to the UV light hitting the ink, the varnish, whatever you're curing. So the main issue is that we are curing, we're not drying. Conventional printing involves drying. So either infrared lamps producing heat to dry, going through a heat tunnel, heat being involved in some way to dry the ink. With UV, we are curing the ink. Now, I'm going to jump off here and show you a couple things. And hopefully you can see them. All right, this is a UV lamp. And hopefully you can see there's no filament in this lamp. It's a clear tube of quartz, except if you can see this ball rolling, looks like a metal silver ball. It is actually liquid mercury. And before you fire the lamp for this time, you can see this ball of mercury rolling around before it's dispersed. And now actually, as I'm doing it, the mercury is split into 5 different balls. The amount of mercury in the lamp sets the voltage. So the more mercury, the higher the voltage of this lamp. The last thing I want to show you that I need, I don't have a filament, I have a ball of mercury, but I need a pressurized environment. So this with high voltage, I can see that I have a pressurized. The light starts to emit. So I have to have pressure, a pressurized lamp. If I have a lamp like this, which has seen better days, you can see nothing happens. This lamp is dead. It's no longer pressurized. It'll never fire. So it is possible that in transit, a leak developed and you might get a non-pressurized lamp. That lamp's never going to fire. But it's very rare for that to happen, but it can. Okay, so what are the key elements in curing? Well, we need very high power, number one. So your input voltage and current to the plant is not sufficient to get the voltage and amperage that the UV lamp requires. So we need a transformer and some kind of device that's going to store current, so we can significantly increase both. The transformer is going to increase the voltage. The lamp I just showed you is looking for about 2,000 volts. So clearly you don't have that coming into the plant, so we have a transformer. Second thing we need is, in a magnetic system, we need capacitors, and they store the current. And initially, I use current to fire the lamp. That's the force that disperses the mercury ball, creates the arc. After that, the current falls, the voltage rises until we hit the equilibrium point where the transformer is generating 2,000 volts, the lamp is dosed at 2,000 volts. So we need extremely high power. Second thing we need that's absolutely critical is cooling. We need a robust cooling system. These lamps generate huge amount of heat. We don't want the heat, but it's a byproduct of UV. So I need to control the heat. In general, the lamp is going to run normally at 1650 Fahrenheit. That's a huge amount of heat, and that's normal operating. I'm trying to keep it at that level. If the cooling isn't sufficient, I'm going to quickly go to 2,500, 3,000 degrees Fahrenheit. I'm going to melt these lamps. So the cooling system is absolutely critical. The third element is shielding. I need a cassette to put this lamp in that typically has a shutter, so I can protect the operator from the light, which will hurt your eyes, from the heat, which will be very deadly, from the power, which will kill you. So shielding is very, very important as well. Next element is the UV inks have to be properly mixed. If we don't have the correct amount of photo initiators in the ink, we're not going to cure. Photo initiators are very expensive. So the ink suppliers don't want to put in too many because it costs a lot of money, but they don't want to put in too few or we're not going to cure. So the UV ink has to be right. Then the lamps have to be correctly dosed with mercury. I need to know what the voltage coming off the transformer is, and I need to make the lamp respond to that voltage within 5%. And the final thing we need to do, and the thing we think about last, is this system just doesn't go on and off forever. This requires regular maintenance, which we're going to talk about. The main components of the UV system. Let me start by talking about what does it cost to add the UV lamp to an existing system. In general, you're going to look at $40,000 to $50,000 a lamp. It's a lot of money. It's a lot of money because the power supply is expensive, the cooling system is expensive, the cassette is expensive. The reflectors aren't so expensive, but extremely important. The lamps aren't as expensive, but extremely important. The switching relay is only a few $100. And then there's a bunch of wiring, ceramics, and sensors that are all part of this system. But it's $40,000 to $50,000 per lamp. So it's a complicated system. It's not like turning the light in your kitchen on and off. Why is maintenance so critical? Well, as I mentioned, you're dealing with extremely high heat. Quartz softens and melts at 2,500 to 3,000 degrees Fahrenheit. We will get there quickly within a minute or two without cooling. The aluminum reflectors on most systems actually soften and melt at a much lower point at 1,100 to 1,300, and the lamp is normally operating at 1,650. So why aren't the reflectors melting? Well, sometimes they do, but if your cooling system is working correctly, your reflector sits an inch or two behind the back of the lamp, and the cooling prevents that high lamp heat from reaching your reflector. Unless you try to make your own reflector, which I highly discourage you from doing. The reflectors have to be shaped and fit exactly. There can't be any kind of bumps, bulges, air pockets, or the reflector will melt. It needs to lie exactly flat on the extrusion. So don't try to make your own reflectors. Buy them from the OEM, buy them from me, make sure they fit. Now, over time, your system is going to be subjected to overheating, and you're going to start to experience metal fatigue on the shutters and the extrusions. They're going to start to warp. They're going to start to change shape. The shutters won't close correctly. So we really need to keep a close eye on the overheating so that doesn't happen. Your main weapon in preventing bad things from happening to your UV system is weekly inspection, weekly cleaning, bi-weekly inspection, cleaning if you can't do it weekly, and a minimum monthly. Otherwise, bad things are going to happen. So let's talk about each component and the things you have to look for. There's two types of power supplies, magnetic ballast and electronic ballast. Your US systems tend to have magnetic ballast, which are the big transformers with the copper windings. The problem is the footprint is very large generally, but these magnetic ballasts go on and on and on, and we can keep them going forever, replace them forever. They typically will go 10, 15, 20 years unless there's some kind of abuse. So you want to pay attention to the age, and you want to pay very close attention. If you start hearing noise, you're days away from failure on a magnetic ballast. And you don't want that ballast to go down, because if it goes down, these are not stock items, and it's going to take weeks to get a new magnetic ballast. Magnetic ballast have a bank of high capacity capacitors or high voltage capacitors, and we need to keep a close eye on those. And typically, when you inspect those, you're looking for swelling, making sure the connections are all working together. They are jumped in parallel. There's usually 3, 4, 5, 6 of them in parallel. So we want to make sure all the connections are good, because if you lose a cap, your overall power goes down, and you may experience lamps starting to drop in and drop out. They fire, they drop out, they fire, they drop out. Electronic ballasts are much harder to deal with because you don't usually get much warning when they're going. And they don't last as long, and after a few years, parts are hard to come by. So I recommend try to keep a spare if you can afford it, because you never know when one of these things goes. When it goes, you're going to be out of business for a period of time. Your power switching relays can be electronic or mercury. They tend to last a long time. The only warning you're going to get there when they stick is when you switch from low medium to high or low to high, you won't see the intensity of the lamp change. When you don't see that intensity change, you've probably got a bad relay. These relays are very inexpensive and very easy to change out. All right, so then we talk about the cooling system. Cooling system is, if it's air only, you got to keep the air lines clear and straight. I see situations where the airline is bent around another piece of equipment going sideways. It's like your air conditioning system in your house. We want clean lines so the air can flow from end. Second thing we want to pay attention to is fan speed. In the summer, if it's hotter in the plant, we want to increase our fan speed. In the winter, we want to decrease it because it's colder in the plant. There is such a thing as overcooling, which I'll talk about later. So we can get too cold or we can get too high. We don't want that to happen. The second system is air and water. So we have two things going. The air system is the same. The air flows from end to end in the lamp. With a water system, we have water flowing through the metal, the aluminum extrusion that the lamp sits in, the housing. We want to keep, that's chiller water. We want to keep our chiller water as close to 72 throughout the year as we can. If we get down to 60 in the winter, we're going to overcool, the lamps may not fire. If we get above 80 at any time, the lamps are going to start to overheat. They may bow, they may bulge, and will create that long-term warping of the shutters or the extrusions. Water and electricity don't mix well. So if you see any signs of a water leak, you need to stop and fix it right away. Because if you don't, we're going to have a real big problem when the water reaches the electrical components. All right, now we have reflectors. This is, without doubt, the most overlooked maintenance item you're dealing with. The lamp I showed you emits 360 degrees, non-directional. The UV light is coming out of the full circle. So half your UV power is coming off the front of the lamp, half's coming off the back of the lamp. So if you aren't reflecting that light back to the substrate, you're losing 50% of your total UV power. It's going to require more energy to cure because you're only using half the power. You're going to cure poorly because you only are using half the power. And eventually you're going to have metal fatigue because in addition to reflecting UV light, the reflector laying flat against the extrusion behind the lamp actually transmits the infrared heat to the extrusion and away from the lamp substrate. Part of your regular cleaning has to be wiping down the reflectors weekly, bi-weekly. Soft, low fiber cotton cloth with at least 70% isopropyl alcohol. And you want to just be wiping these things down because they attract external contaminants. And once those contaminants get baked on, you're not going to get them off. And once they're baked on, you are not getting reflectivity and you're not getting heat transmission. So reflectors, everybody hates because they're hard to change and it takes too much time. But They're extremely important. They're half your UV light goes back to them. So you want to use them to your benefit. Now there's 4 types of reflectors. I'm going to show you these a little later. They may be polished aluminum, which is most common. They can be dichroically coated aluminum, which is a coating that actually enhances reflectivity and helps heat transmission. There is dichroic coated quartz that you typically see on IST systems. There is dichroic coated slumped glass, which you see often on GEW systems. Slumped glass is glass. It's like a Pyrex. It is not good in high temperature applications. So it's an old Japanese technique from the 1800s. And I'm not a big fan of it because slumped glass tends not to hold up, it tends to crack, tends to break. So there are solutions around using slumped glass, which if you want to give me a call at any point to discuss what they are, I may be able to help you with those. All right, now the most overrated part of a UV system is the lamps themselves. As soon as something goes wrong, our first inclination is it's a bad lamp. It has to be a bad lamp. When I'm in my kitchen, I flip the light, it doesn't go on, it's a bad light bulb. In this case, try not to make that conclusion too quickly. In most cases, it's not going to be the lamp, it's going to be something else. So before you conclude it's a bad lamp, give me a call so we can talk it through. Extending lamp life, again, is a question of cleaning, low fiber cotton cloth, isopropyl alcohol, wipe it gently down completely to get any of the contaminants off. I have customers who faithfully clean their lamps and reflectors every week, and they get in excess of 2,000 hours out of their lamps. I don't have many customers who can do that, but it really can extend the life of the lamp. Any lamp that goes over 2,000 or 2,500 hours, I highly recommend that you just change out in general, because the quartz does start to degrade, the output starts to go down, and you shouldn't try to just keep them going to 3,000 or more hours, even if they're still lighting. So watch for any form of external contamination, watch for bulging, bowing, or mirrored ends. If you have long wired lamps that tend to bow, at each inspection and cleaning, turn that lamp a quarter of a turn. And the reason for that is we're trying to offset gravity. So if the low point is at the bottom, I want to move that low point to the side. And next week, I want to move that low point to the top. And then back and forth to try to offset that. That'll help offset bowing. The most important thing you can do is adapt a preventive maintenance schedule. If you see in general that your lamps are lasting 1,500 hours, set a preventive maintenance schedule at 1,400 hours. And you say, well, I can get another 100 hours out of the lamp. The cost or the savings of another 100 hours on a lamp that costs a couple $100 is a couple dollars. If you go down in the middle of a job, you lose a lamp, it's going to cost you a lot more. Stop the press, to change out the lamp, to let the system reset, have everybody standing around while we get back in business. So I highly recommend preventive maintenance schedule. I know that run to failure is often the course we choose to follow. But if you can come up with a good PM schedule, it will save you money in the long run. Okay, now I'm going to show you all the things I've been talking about. All right, so the first thing, I don't have a magnetic balance, but I do have a capacitor. These are high voltage capacitors that are used in UV systems in the United States. They tend to be low microfarad, high voltage. They are jumped in parallel. They hold our current. So when these are fully loaded, I fire the lamp with the current that's held in these 4 or 5 capacitors. So very important, you check to make sure they're not swollen, the connections are good, because if one or more are bad, we're not going to get the current to get the power. The next thing is reflectors. Okay, this is the most frequent reflector that you see, just polished aluminum. There is a, these always come with a plastic coating, which is sometimes difficult to get off. But you need to take the protective coating off before you install this. And as you can see, this is a 360 radius. It has to be ruled correctly. It has to lay flat against the extrusion. Okay, this is a dichroically coated aluminum reflector. It has the coating that enhances reflectivity, enhances heat transmission. This is a coated quartz reflector that again enhances UV reflectivity, transmits heat. This is a GW slumped glass reflector. And as you may be able to see, this is not a uniform radius. It's a slumped glass. It's a old technique where you curve it, but it's really not it's not a 360 radius, it's something else. And again, it's glass, which doesn't handle heat. Lamps. Okay, I showed you a good lamp. Now I'm going to show you a bad lamp. I think you can see this lamp is bowed. Gravity has pulled the center down towards the middle. And more than that, you can see that the lamp actually in the middle is fatter. So we are actually deforming this lamp. And the reason we're deforming it is a result of 2 things. We have a lamp that's heavily contaminated here. So the UV light is being trapped, the heat is being trapped. It's killing the electrodes in the lamps. And it is starting to literally melt. Now here's one that isn't bowed, but it is completely covered with contaminants. There is no UV light coming out of this lamp. Now, the scary part is, here's my bowed, deformed lamp. Uh-oh. It still fires. So if you're running to failure, this is what you could be using. And it's still lights, but you're not getting much UV light out of this lamp. So again, inspect your lamps, inspect the reflectors, know what's going on with the system. All right. UV cassette. got a shutter that opens, closes, the lamp goes inside, the reflectors go inside. You may have one that's 12 inches, you may have one that's 60 inches. If you're doing wide format stuff, the lamps go out to 120 inches, so you may have a monster cassette. But this is what provides the shielding, contains the lamp, contains the heat. Okay, so all right, now let's talk quickly about evaluation tools. Some customers like to really try to measure the UV output, and there are measurement tools called radiometers. They are affixed to the cassette. There has to be a hole drilled. We've got to put the probe into a fixed location on the press and then read the output in millijoules. Now, when you first use it, I get the phone call often that says, okay, well, Norm, what does that mean? And I have to say, in all honesty, I have no idea what it means. And the reason for that is if you want to use a radiometer, we need to set benchmarks. So we need to, every day for a month or two, take readings and see where, what kind of energy output we're normally getting. These things are affected by a number of different things: temperature, speed, time, and the readings can go all over the place. So I typically am not a proponent of radiometers unless you're really good at data recording. I would not be good at it. I don't really have any customers who use them anymore. They buy them, but within a month or two, they tend to abandon them. Something a little simpler is test strips. And I don't sell them, but I can tell you who does. And these are just a sticker, color coded, that you stick on your substrate, run it under the UV light, and it gives you a color coded idea of what your UV output is: great, good, fair, poor. I have no problem with them, but with most of my customers, I tell them, you know when you're curing and when you're not curing, based on the product you're producing. So I tend just to go with what's the output we're producing, and if it's not curing, we tend to know it's not curing. If it's curing, we know that. The last tool is what you've seen me use today when I hit these lamps. It's called a high frequency generator, called a coil tester. It's called a pinhole detector. It is the best thing I have in my toolbox that I take with me wherever I go. I even have to talk my way through TSA with it, but it is a great, great tool because I immediately know if I have a good lamp or not. So not expensive, under $500. I do sell them, highly recommend them. Briefly, I want to hit on UV LED, if you've heard of UV LED. It's the new thing on the block. It's the same concept as conventional, but it's a totally different approach. It uses very low energy, produces very low heat. We love that. That's great stuff. But it has a very narrow curing spectrum, which we measure in nanometers. Conventional UV is like a broadband antibiotic your doctor gives you. We don't know exactly what's wrong with you, but this will kill everything. Conventional UV tends to be the same way. we produce UV from 180 to over 500 nanometers and focus it around 365. So we hit a lot of wavelengths. And like I tend to say, we get the photo initiators moving before we get the 365. And so they're ready to go when we hit it with good UV light. With UV LED, the spectrum is very, very narrow. It's like 360 to 370, 360 to 380, and that's a very narrow band. So the ink is not just UV ink, it's UV LED link. It has to be dead on to work. And when it works, it's great. And when it doesn't work, it's not so great. But it is getting better, and it's come a long way in the last 10 years. If you're thinking about UV LED, I recommend a hybrid system. That's what all my customers are using. So a hybrid system is maybe 3 or 4 conventional UV stations, 1 or 2 UV LED stations. So if I'm not curing LED, I can bring in the conventional to get the job done. I've had customers call me and say, Norm, really loved working with you. I got UV LED now, never going to sell me another lamp. And 2 or 3 months later, I hear from them and they need more lamps. And I do not say, I thought I was never going to hear from you again. I say, thanks, I appreciate the business. So that's where UV LED is. Some common questions I get. What's Norm? What's my UV output in watts per inch? And the real answer is I don't know. Reason I don't know is your power supply dictates that. So the lamp is only responding to power. So I don't know how much, what the voltage is. It's probably, if the lamp is working, I'm probably plus or minus 5%. But then I don't know what the current is because I don't know what the capacitor bank looks like or the electronic ballast setup. So the watts per inch totally set by the power supply. The lamp only responds. I can ballpark it for you, but sometimes I can be really off if people have added capacitors to increase the output. Next common question, my UV system worked great for 3 years, but the lamps just don't seem to last. First question I have there is, what maintenance are you doing? And sometimes the answer to the question is, well, when the lamps fail, we change them. And so the answer to that question is, we need to get onto maintenance of the UV system, and we need to start with everything: reflectors, cleaning, inspecting, capacitors. So maintenance, this system is not going to go on and on forever. It has to be maintained. The lamps fire and drop out. The current fires the lamp. If it drops out, it could be misdosing, underdosing, overdosing of the lamp, or it could be a bad capacitor. So call me and we can talk about that. I've used anniversary lamps for years, but now they don't cure. First question, have you changed ink suppliers? And the answer often is, how did you know that? You're trying to save money. Business is tough. We need to be efficient. But the lamp, if we're reducing the price of the ink, we may be doing something with the photo initiators. If we don't have enough photo initiators, we're not going to cure well. I put in a new lamp, it won't fire. These systems need to go through a cycle, 3, 4, 5, 6, 7 minutes sometimes before they fire the lamp. You can try to jump start it, but when you try to jump start it, you will not succeed. And then we start all over. And the system's going to take 5, 6, 7 minutes to refire. So leave it alone, let it do its thing, let it run through its cycle. Lastly, why do you need a working sample lamp? If I can't tell you what the lamp is based on the part number you give me, and I say I need a working lamp, it's because I need to figure out the voltage. And we have a system where we fire these lamps, we can determine the voltage. But when you say, I just want the 30-inch lamp, well, there's 50 30-inch lamps because they all have different voltage. So that's why I need a working sample lamp. I know it's a hassle, but it's the only way to really hone in on what lamp you exactly need. So that's it for me. Wendy, I'll turn it back over to you.
Yeah.
For any questions.
Thank you, Norm. It was a great presentation. I love that you were giving us some visuals too and showing us some demonstrations of the equipment. Everyone, I'd like to, if you have a question, you can raise your hand. Zoom has a raise hand function at the bottom of your screen under the reactions. There's a smiley face. You can click on that and just click on the raise hand function. Or you can put your question in the chat box. And while everyone's thinking of their questions, I have a question. Which, oops, looks like you just shared your screen, Norm. Did you mean to do that? Yep.
Let me unshare it.
Yep. So one of the questions that I had, Norm, is for someone that hasn't yet put the done a UV installation. What are some of the things they should be considering before they even put this UV equipment in? What are some of the factors to consider when looking to do an upgrade to their equipment for UV?
Right. The main benefit of UV is speed of production. So once we put in UV, we can really significantly increase line speed, whether you have a web or a sheet fed. We can run these presses as fast as they can go pretty much because we're curing instantly. So we don't have to worry about dry time. And so speed of production, you can turn a job much, much faster with UV, but it's expensive. The other element is if you are starting to run 6 days a week, 7 days a week, 24 hours, UV can really help you with production and potentially reducing overtime. And these systems, conventional systems, particularly with magnetic ballasts, they can last and last and last. I'm servicing UV presses that are 25, 30, 35 years old because I can replace the magnetic ballasts, I can place the capacitors, the switching relays, the reflectors, the lamps. But it's a big investment, but it's speed of production that really is going to be your payoff.
Okay, that's really helpful. Thank you. And is there anything, equipment wise or anything that someone looking to make this change or should be looking for or anything, as they're making these purchases, going to make these purchases, is there anything they should be kind of keeping an eye out for?
Well, I use a UV manufacturer to design these add-on systems. So we come, we look at the press, we see where we can put the UV units, get an idea of how many stations are needed, given the kind of work that you're doing. So it's a long process of understanding needs, designing the system, and then building the system, which right now is about 3 to 4 to 5 months to get it installed. We install it, we test it. Because these systems are new, they are state of the art. They're conventional, but they produce very little heat. They do have electronic backups not magnetic, because for space, the electronic ballast is a space saving tool. So we've had very good success with add-on on an existing press. But again, it's probably 40,000, 50,000 per lamp. So let's say you're going to take a press and put on 4 stations, you're looking at a couple $100,000.
Okay.
So you really need to run the numbers, look at the work you've got, and make sure that you can justify the investment, because it's a big investment, and then there is a learning curve to UV. It's a little bit counterintuitive, because again, our frame of reference is the light bulbs in our house, and unfortunately that's not a good frame of reference. So you've got to sort of take some time to get to know the system, how it operates. It's not hard, but it takes a couple months before you really understand it. But once you understand it, it's really very, very simple.
Okay, that's very helpful. And then I'm definitely hearing that there's, you are kind of soup to nuts with this. I mean, you're not just a lamp manufacturer, that you're actually providing some, going on site. Tell me, and John has a question too, but tell me what you do for your customers when they reach out to you.
That's a really good question, because my customers, I tend to ask a lot of questions, and my customers will say, "Norm, you were a terrible salesman." And I tell them, my job is to solve the problem. That's what I really like. And I don't want to sell you a lamp if it's not going to work.
Yeah.
I want to figure out what's wrong, fix it, so you come back and trust me and use me over the long term. And that's really what I enjoy about my job, is, really figuring out why something's not curing, what do we need to do to fix it, and keep people going. I had a customer in Maryland who was going through several hundred UV lamps a year, and it was because we were overheating, and I knew it was the chiller water, and because it was 90 degrees, and I kept saying, if we could fix this chiller water, you wouldn't need all these UV lamps, because you wouldn't be burning them up. And it took a couple of years, and then he called me and he said, "Norm, I fixed that chiller system." So the lamp usage went from about 300 lamps a year to 50 lamps a year, which speaks to what a bad salesman I am. But we fixed the system. We let it operate correctly. And that's what I like to do. I want you to get value for your money.
Excellent. Thank you. John, it looks like John Braceland has a question.
Yes, Norm, one of the things I've heard from members before in the past is, that when they buy a press, or they've had a press in, the manufacturer, they normally buy their replacement lamps or replacement parts or things like that from the manufacturer. And one of the things that they're concerned about is if they buy their lamps or other UV parts from somebody other than the manufacturer, it could lead to problems, and that they don't want to mess with that. So they're just going to buy everything from the manufacturer, and that's kind of the safe way to deal with things. So could you maybe address that question, and also talk about maybe what the savings or the differences are in terms of relative pricing between what your products and what a manufacturer would typically charge, or a little bit about how that whole equation works, because that's a big issue that I have run into in the past with members not wanting to switch away from the manufacturer.
John, that's an excellent question. And my advice is, during the warranty period, use only the manufacturer's recommendations. Once the warranty period ends, you can more easily switch to consumables that come from other people like myself. US companies after the warranty period tend not to be a problem. It tends to be Heidelberg presses, IST systems, generally German companies. In Europe, they have tying agreements, and tying agreements mean that when you buy the press, you have to buy all the consumables. In the United States, tying agreements are illegal, but that's not going to stop Heidelberg or IST, and it's usually Heidelberg sees some other lamps from reading you the riot act and telling you you can't do that. With my very large customers, that tends not to be a problem because they can easily push back on Heidelberg, and they do. But with smaller customers, it's a lot harder to push back on Heidelberg. So with my smaller customers who buy IST lamps or any of the German lamps that come on Heidelberg's, KBA, I always tell them, keep a spare set. If you call for service, put the KBA lamps in, IST lamps in. A lot of my customers do that because they know the game. And I wish we didn't have to do that, but if you don't want somebody screaming in your face, sometimes, that's what you have to do. But legally, there is no justification for telling you after the warranty period, you can't use whatever lamps, reflectors you want to use. But consumables are a big money maker for Heidelberg, big money maker for KBA. So that initial lamp I showed you, which was a 42-inch arc lamp, is an IST lamp. IST Heidelberg will happily sell you that lamp for $1,000 per lamp. Our GAA price on that lamp is $329. So it's a third of what Heidelberg charges. Now, the only difference in that lamp is that the IST Heidelberg KBA lamp is likely made in China. Our lamps are made in the United States. But they're Heidelberg, so you get to pay 3 times what the price should be because, Heidelberg's a great brand name and you get to pay a lot more if you want to go that route. So sadly, that is the situation. I completely understand it. And when customers are uncomfortable and just say, I just want to keep buying from Heidelberg, I know I'm overpaying, I just say, hey, I totally understand. You have to be comfortable. I'm not gonna, strong arm you, if you're not comfortable. It's your decision. It costs a lot more, but if it makes you comfortable, that's what you should do.
Great, thanks, Norm. Good answer.
Thank you.
Great. Thank you, Norm. Did anyone else have any other questions? We are wrapping up on the hour here, and I don't see any other raised hands. So, Norm, thank you again for bringing us to this wonderful understanding of UV. For me, it was extremely educational. For those who are using UV, I hope they got some really great pointers on how to maintain their systems nicely, so that they are getting better shelf life with their lamps and understanding how to improve their curing processes. So thank you again. Of course, Norm is a Graphic Arts Alliance vendor. He does offer some special pricing to Graphic Arts Alliance members. So we definitely encourage those of you who are members of GAA to reach out. And for those of you who might be seeing this video down the road on YouTube and you're not a member, look into joining. Norm, any other last thoughts?
No, thanks for the opportunity, Wendy. As you can tell, I'm one of like 3 people in the United States who really like this UV stuff. So I tend to get a little long-winded, but I appreciate the opportunity very much.
No, thank you very much, Norm. We really appreciate it. It's been a pleasure. Have a wonderful day, everyone. Thank you.
Thank you.